Hello all. Today I am going to discuss about this question related to logic gates, which came in NEET 2024 this year. So I'll tell the methodology to solve this question. These are the four options like OR gate and or NAND NOR. So what should we do is never try to solve this question by doing a Boolean algebra. So like for example, I will begin by solving in a conventional method. First thing is to identify the logic gates. This one is NAND gate, this is NAND gate, these two are NOR gates. So after identifying the gates, you have to know the expression. What is the expression for NAND gate? NAND gate is like, for example, there are two inputs. So NAND gate is not of AND gate, A dot B whole bar, if two inputs are A and B. Similarly, NOT gate expression is like A plus B whole bar. So these two expressions we need to know. So before starting, I will solve in a conventional manner. Like when both inputs are A, so what will happen? This and this are A. So A dot A is A dot A is A. This is Boolean algebra. A dot A is A. So A dot A whole bar is A bar. Similarly B plus B is also B. B plus B is also B bar. So now what can I do? Y is equal to, instead of A, the input is A bar, and then instead of B, the input is B bar, then whole bar. So you have to know the De Morgan's law for this. X plus Y whole bar is equal to X bar into Y bar. So this is De Morgan's law. I am just saying this is a conventional method, but you don't need to do this at all. But you have to know the both methods always, conventional method and shortcut. So I have to tell both the things in this video. So now if I use this rule, then X bar is A bar whole bar. So there's one more rule, is that A bar whole bar is nothing but A. 2 times NOT gate is nothing but NOT of NOT is same only. It is nullified. So A bar whole bar dot B bar. So it is nothing but A dot B, right? Simple. So this implies A dot B is expression of AND gate. So this is the answer. But there are so many things which you have to remember, like A dot A is A, B plus B is B, and this De Morgan's law. So instead of doing that, what we can do is take two inputs. Like let me assume that A is equal to 0 and B is equal to 0. Since the options, first you have to look at the options, and you can see that one has to be thorough with the truth table of each gates and also the output expressions. So you have to remember that, and also you can derive it if you don't remember. You have to try to remember that. So what happens is, that when both are 0, both inputs are 0, OR gate output is 0 and AND gate output is 0, but NAND and NOR will give 1. So by using this option of A 0, B 0, we can eliminate two options. So we will proceed like this here. We'll proceed like this. So 0 0, as you know the expression, you have to note this expressions of NAND, and this is expression for NAND, and this is for NOR gate. So you have to note this out. So now it is 0 plus 0 into 0 whole bar. 0 into 0 is 0. 0 dot 0 whole bar is 1. Okay, let me draw here 1. I will take this out. Let me take this out now. A plus B. So now if I take this, what happens is that 0 into 0, let me write it, A is 0 and B is 0, 0 dot 0 whole bar, that is 0 into 0, 1. So this will give 1. So this output is 1. As you know, no need to do this also, like you have to remember the truth table for NAND gate. Let me write it 0 0 output for NAND 0 0 it is 1, 0 1 it is 0 into 1 whole bar, so it is 1, 1 0 it is still 1, for 1 1 it is 0. So for NOR gate, let me write it 0 0 0 plus 0 1, 0 1 it is 0, 1 0 it is still 0, 1 1 it is 0. So this is what is the truth table. From this truth table, when both inputs are 0, you can see that output is 1, and also when both inputs are 0 for NOR gate, output is 1 again. So now for 1 1, the truth table says that the output is 0. So here output is 0. As you know that when 0 0, I'll write the truth table of OR gate and AND as well to be more clear. A, B output 0 0 0, and for all other combinations you get 1. And similarly, for this it is going to be only for 1 1 it will be 1, else it is 0. So 0 0 0 0 1 0 1 0 0 1 1 it is 1. So now you can see for 0 0 for OR and AND gate, for 0 0 OR and AND gate, you will get as for OR and AND gate, if I take 0 0, then the output is 0. So the option and NAND and NOR gate are eliminated. So these two options are eliminated now. So the option can be either OR, NAND or AND. So now how we will test it? Don't test all the combinations. For example, you see which for which inputs the output is different. Let me take 1 0. If I take 1 0, for AND gate you get 0 and for OR gate we get 1. So we can easily differentiate it. So now I'm going to take 1 0 for simplicity. Let me keep that. I will write like this 1 1, now 1 0. So if I take 1 1, what is the output of when both the inputs are 1, the output is 0. I will write like this 0. And again for NOR gate, if I take 0 0, what is the output? 1. So this remains same. So now 0 comma 0, 0 comma 1 is the combination, input combination for NOR gate. Then 0 comma 1, the output is 0. So now you can see that for AND gate the output is 0. So this is going to be AND gate. So this comes with practice, that if you remember the truth table and the expression, then you can, if you remember the truth table and the expression, you can easily do this with practice. This is a shortcut, don't need to do the Boolean algebra. Thank you. I will continue with one more question in the next video.